So welcome everybody to the British Astronomical Association Hydrogen Line group. It's great to see you tonight, and I don't know what the weather's like where you are, but round here we've got a bit of snow, and it's lovely and clear outside. I was going to go out earlier and stick something on the radio telescope. I was actually going to change the LNA over to a bare bones to give it a try, but as it involved stripping it down, I walked out and it was freezing cold. I turned around and came back in again. So I was going to show you the effect of that this evening, but you're going to have to wait till next time. Anyway, last time we met, Sharma here was telling us a little bit about his own project, and I've got to say it's one of the most inspiring things that I've heard recently, and he's very kindly offered to tell us a bit more about it and what he achieved. We're I think always particularly interested in anyone who manages to achieve miracles with virtually nothing, and because that's really what's going to encourage other people out there to join the hobby. Anybody can do anything for £10,000 or $10,000, but it's when you can when you're innovative and try things in a different way that really excites us all. So would you be ready to go now, Sharma?
Yeah, by the way, I'm Sheikh.
Sheikh, apologies, sorry. Yeah. That was, I'll start again. You corrected me earlier on about that. I called you Sharma earlier on tonight. I do deeply apologise, Sheikh. So Sheikh Pasha, yes. Give me. Anyway. Yes. Well, Sheikh, thank you very much for offering to talk to us this evening. If I could pass the floor over to you now. Do you know how to share your screen?
Yeah, yes.
Okay.
I will be sharing. Can you see my screen?
Indeed, yes.
Yeah. So in my last meet, I was sharing about my experiments with radio telescopes, and so as in the last meet, I have shared you about my parabolic dish I made with cardboard and aluminium foil. So I will be sharing you how I made it, like how in a low cost I can make it. So basically it's a parabolic formula. I used it. So I took a cardboard sheet and draw a scale, and for each centimeter I used these points. I pointed. Oh, sorry. Yeah. So I pointed it on the scale for each centimeter accuracy, what should be the point to make a perfect parabolic strip. And then I have drawn the scale lines on this cardboard sheet, and then marked each point on it, make a parabolic strip size, and then I cutted it. So I made it for 120 meter dish, 60 centimeter each strip. So it has a focus of 80 centimeter, 0.6 f by d. So later I cutted these strips something 20 to 30, and I arranged it circularly on a base. It's I used a very small cardboard base, but I shifted later onto a very basic rigid base to hold the strip properly on the base. And after making the whole arrangement, I glued them. So later on, I have compensated smaller strips on the other side to hold a paper on it. So later what I did is I pasted a small amount of papers on it so that I can give it a surface, a parabolic surface. So similarly, I have arranged 2 to 3 layers of paper to make it a smooth surface and hold to make a parabolic surface and hold the aluminium foil onto the head. So later what I did is I pasted aluminium foil on the surface to make it reflecting surface. So it is somewhat not easy thing, it is very fragile. So I have to paste 2 to 3 layers of aluminium foil to make it very smooth onto the surface. So this is how I constructed my cardboard aluminium foil dish. So later I have used this. So I have made a small horn feed with a aluminium foil and a thermocol. So like at first I have recorded this. There was some RFIs. Later I filtered that, and like I've seen this, and there was like a lot of interference from surrounding. So it was very closed area. And later I've shifted another feed. So like I'm still working on the feed part. This dish is working fine, I guess. Like I've checked it. I'm just working on the receiver's part. So this was the another feed. I've changed it. So it was something like 4 to 5 hours of drip scan I've taken. So there were some RFIs in the same region. So yeah, this is what I'm doing with this cardboard dish.
Wow, thank you very much indeed. That's really interesting. Is there anybody who would like to make any comments or ask any questions about that?
What was that second feed? The second one that you used? What I couldn't quite make it out in your picture.
Okay, so it was a small loop monopole. So
Oh,
it
okay.
was a similar one which Alex uses.
Right.
Yeah, so like I've used that and added a small reflector. So yeah, this.
That's excellent.
How big is your dish?
It is 120 centimeters diameter.
120, gosh.
Yeah.
Sheikh, Dave Bracey here. I found that very impressive. Well done. Especially for 1.2 meters from cardboard. I think that's incredible. How did you provide any additional support to the antenna to stop it from twisting? Did you get some torsion or rigidity?
So like,
have any issues there?
Yeah. So like, as I told you, first I used a small cardboard base. So at that time I had a lot of issues. So that the whole parabolic circular thing has to be maintained. So later I changed the base to a somewhat like 3 layers of cardboard at the base, so that it will be very rigid. And then like it was like very good now. Not that much of issues, like I can manage it.
That's superb. And have you been able to orient the dish to angles that are so it's not base not horizontal, but I don't know.
Yeah, I am able to do that. So like I have a stand. This stand was for just a minute. So this stand is I basically made it for my horn antenna. So like I adjusted my this parabolic dish onto that same stand. So like I can rotate this thing. So there is some structure. Just a minute. I will share that thing. There's a so this was my horn antenna.
Yep.
So this was my stand.
Yep.
So like I have adjusted the parabolic dish onto the stand so that I can move any elevation I want.
Yeah. Very impressive. Is that also a welded steel construction or bolted?
Yes. Yeah, it is a bolted.
It's bolted, yeah. That's really good.
Yes.
Yeah. Okay. Yeah. Thank you for showing me that. That's very impressive. Yeah. I mean, I've built. I've built a parabolic. I know how difficult it is to do it and to keep the shape. And I found that vastly impressive. Well done.
Yeah. Thank you.
Are there any other comments?
Yeah, Sheikh, that was most impressive. I loved it. What's the next phase of the project with your cardboard dish?
Right now, like 3 months back, I made it. So I have started my masters in my university. So like I have to move to another city. So I've stopped it, working on it. So whenever I get time, when I go home back, I will start working on it. So like I need to update my feed.
Yes.
So I'm still working on my feed part, and also I'm trying to make a new radio telescope for 1420 megahertz here in my university. So like still I'm on designing part. So yeah, working.
Okay. Yeah, I mean, that's very impressive. For a student to be able to do that in your spare time. I mean, some of us are retired and we still can't find time to do things. So yeah, well done. That's most impressive.
Yeah, thank you.
On your first horn, did you get any results on the first antenna? Oh,
Yes.
okay.
I will share it. Yes, right. So this was my first horn antenna. So like it was my first test with the SDR short software.
Shake.
Then later,
So sorry, forgive me, Shake.
that,
So forgive me, Shake. I see you have a little bit of a presentation that you keep dipping into on your horn antenna. Would you perhaps like to show us that presentation? It looks very interesting. I mean, I don't know whether you have the time to and the inclination to go
sure.
through it. You could start at the beginning,
Yeah,
go through it
sure.
if you wanted.
Yeah, okay, I will agree. So like this was my first horn antenna project. So this is called Chandra Horn Antenna Radio Telescope, named after like Chandra Subramaniam Chandrasekhar. So like we I was into a radio astronomy winter school in India, where I got introduced to radio astronomy in there. So like after coming there, I got really interested into it, and I made this thing with a professor affiliated to them. So like I made this first waveguide, and like I have tested it, and then I have attached a flare, and this was my first results. Later, we tried to make our own pipeline to analyze to collect the data and analyze it. So like we have collected the data and sky and ground reference, and after calibration, this was our first profile. So later we have done the corrections of LSR corrections and try to plot like a rotation curve. So we have we are trying to find different methods to find the terminal velocity for like very higher beam width telescope observation. So like we got few results, and we have like a comparative study of different methods here. And later I'm still here working on like to plot the galactic structures, whatever the points I'm getting, to plot it on a XYZ plane with respect to like galactic center. And so this was the velocity longitude plots we got from our first results. And this was the drift scans with the same horn antenna. So I have done this for like many hours, like something from 4 hours to like 27 hours long. So this was some rain effect study. So like I started observing during a very heavy rain again. So it was raining very heavy early. So I started observation, and in middle rain started. So due to water accumulated on the top of the horn antenna, so it was like there was a loss in the signal. So at the time I have seen a rise in the system temperature, and this was a thing when water entered into my feed, and so I have to stop my observation at the time. So later on, after second day, I started my observation again, and this was the result. So here it was the rain again. So later on, as the rain stopped, I have removed the water on top of the horn, and like it was started observing good amount of H1. So this was the this area was completely like rain effect. This one was without rain during the drift scan. And yeah, like this is my parabolic dish. This was the observations with it. And I have my small Yagi type, the same loop monopole Yagi as Alex made it. So I extended that to an Yagi type with a like 5 elements thing. So I got the results. I'm still working on this part. if I go home back in my holidays, I start working on it. So this was my results.
Sheikh, another question. So, what was the aperture of your horn antenna? And secondly, how would you compare the performance that you got from your horn antenna and your parabolic antenna?
So here there is a Bharat antenna, there is an institute here, Ayuka. So they have made a comparative study with the horn antenna. So we compare our results with the results, try to compare the profiles which we got for each longitude, and it is. I'm still working on this antenna, but trying to understand the terminologies and stuff. So this was one Bharat antenna, and there is a lab survey available. So if we give the beam width of the antenna, they will give us a interpolated results of the beam width. So where I compare my whatever the results I'm getting with that antenna with that lab survey, so that I can say whether I'm getting a good performance or not. This is how I compare it till now.
Which do you think, which in your opinion, do you think is the best performing antenna, the horn or the dish?
So horn is the best performing till now.
In what respects?
It has something like 17 dB of gain, and it looks something like it has 2 beam widths, it's pyramidal, so 36 to 26 degrees.
What was the aperture of the horn antenna?
You mean the size?
Yes, sorry.
Yeah, so it is 58 centimeters.
Yeah. Is that square or rectangle?
Yeah,
rectangle?
it's a rectangle.
It's 58. Is 58 the long distance or the
43?
43. Okay.
58, 43, yeah.
Okay. And how did you find the susceptibility to RFI differ between the two?
With horn antenna, I think the structure itself we won't get a lot of effect with the RFIs. I think with horn antenna, due to its this upwards pointing structure, it won't be getting a lot of RFIs in. With this parabolic dish, I think due to my open feed, I was getting a lot of spillovers. I'm still working on designing that feed. With horn antenna, I didn't find major RFIs issue at my region nearby at the 1420 at the frequency too. But with my parabolic, I did find RFIs there.
Okay. Yeah. Interesting. Thank you very much.
Okay, thank you very much indeed. I think that was extremely interesting. It was very kind of you to share that with us, and amazing. 120 centimetres with cardboard. I suppose that raises the challenge now. Is there anybody here who wants to make a 3-metre dish for next time using cardboard or polystyrene, perhaps? Only problem around here is the rain would wipe it out in about 10 seconds, but still.
Yeah, that would be a major issue.
I suppose the next question on a more serious note would be, can you construct a dish with a cardboard frame like that and then backfill the back of the dish with something else to give it more strength, and perhaps fiberglass or something to turn it into a longer lasting device? But perhaps for another day. Anyway.
I suppose you could use chloroplast or something like that. That estate agent signs here are made of, which would be.
Yeah. We are still thinking about it. We are thinking about to make some water-resistant material.
Yeah.
To use it, so that it will be very easier to operate in any type of environment.
Interesting.
Except Ted's environment, he has metal dishes that get folded into tacos by his local wind, so I think maybe a bit of plastic wouldn't work for him. Anyway, thank you very much indeed. That was absolutely fantastic. So, what I would like to do now is perhaps open the floor for other people to talk about their projects, as we have done before. If we are got time at the end, I did prepare a little presentation in case we were short of things to talk about, but that absolutely isn't necessary to talk about if we've got plenty of other things. So I'll start with yourself, Paul, if that's okay. And so I'll go to yourself, and then I'll move over to Andrew Satowski next afterwards. Okay, so because you guys missed out last time, so I want you to have as long as you need or want tonight. Okay.
Yeah, thank you very much. Thank you very much, Andrew. H-line observations is something very new to me. I've been doing other stuff up to the time this group started. And so I'm very new to it. So I'm going to proceed on the basis that there's no such thing as a stupid question. You may recall, let me just share my screen. Share, I think we can probably do this. Oh, window. That one there. Can you see my screen? Did it share?
Yes, it's done very well.
Okay. Yeah, last time, which was the time before last, was my first time at this meeting, which is when I started the project. And just to remind you, I was using a motorized TV satellite dish, and I had no idea how to characterize it or what the offset angle was. And in fact, until I started, I didn't realize, I thought it was a bit of a sphere rather than a bit of a parabola. Anyway, Heather pointed me in the direction of a great tool. So now I know exactly what the offset angle is. So thank you, Heather. Although I don't know that she's here this evening. But that was extremely useful. I have made a start on the stand for it. And I've just got a few slides before I get to my questions. But they're on the other monitor. So I'll stop sharing is down here. Okay. So I'm not really used to Teams. And share a different window, which is this one. Actually, I need to start the presentation. Right. Bear with me. Nearly there. Okay, before the weather got too cold, I was in the workshop with some timber that somebody had given me. So I've made a stand that's 1.6 meters high. It's made in timber, and my dish has a base that will fit the top of the stand. So that's the way I'm organising things mechanically. Why won't it? Oh yeah, there we go. So this was taken from the data. I wanted to check exactly where the focal point was, and so I just made a wooden triangle with the numbers from the formula that I found, and the original TV LNA is sitting here. Can you see my pointer? Is that showing?
Yes.
Yeah. Yes. And my calculated focal point was here, so I was quite pleased with that. I feel like I understand now the geometry of the dish. Then I started work on the head amplifier, and I'm using a sawbird, and you can see I've put it in it's actually in an aluminium box sitting inside a weatherproof container. I'm going to have a USB hub underneath. This is let's just go back. This will sit 10 meters from my lab. So I'm working on having all the stuff at this point in a weatherproof container at the end of a 10-meter cable. So I'm going to have an RG6 line running from the sawbird into my SDR. The USB will just be a short cable because I'm going to have a waterproof hub sitting at the antenna. I'm going to drive the antenna ultimately, and I'm just going to use one of these devices driven from a Raspberry Pi. I just want to give an overview of the architecture. So, how do I've lost the stop sharing button. Do bear with me.
You have stopped sharing already, Paul.
Oh, did it? Oh, that's why the button disappeared. Okay, so I just want to have a look at the top level. Okay, so this is the at the telescope end. So I've got the dish and the head amplifier. I've actually designed an inclinometer, which is a I2C device, and I'm going to drive that over a Cat5 twisted pair with a driver to get the 10 meters. I've designed the PCB for the inclinometer, and I'm just probably this week, in fact, I'll do a test that I can drive successfully over the 10 meter Cat5. The motor drive is a 12 volt 5 amp. They use Bosch windscreen wiper motors in these things, and I'm going to drive that from a Raspberry Pi 5, and I'm going to design a top hat that'll just plug into the top of it and take the the elevation angle, initially anyway, from the inclinometer, and then drive the dish through the H-bridge from the RPI 5. That'd be off a 12 volt lead acid battery running through that. And what else we need to say about this? Yeah, I'm going to take 230 volts up to my USB hub, and all the electronics at this end is going to be sitting in a waterproof instrument box underneath the dish. So that's as far as I've got at the moment. As I say, I have designed the inclinometer schematic and print board, and I'm going to work with my 85 centimeter dish just to get it all working. But I've had some very interesting and helpful discussions with Dave Bracey, and I'm going to build probably a 1.5 meter dish, and then ultimately, if I can get another drive unit, I want to build a second one and do have a phase array. I've got a fair bit of room here in my garden, but that'll probably be a project for 27. If I can get all this working in 26, I'll be very happy. From what I've said, has anybody spotted any screaming errors or stupidities on my part?
What are you using as you described the sort of the amplifier that's at your dish end, but what are you using as the waveguide on there?
Oh yes, yeah. I found some. I found a paper that described how to related waveguide wavelength for the hydrogen line, and so I've actually started building that, but I need to do it in the workshop, and it's been a bit cold this last month, so it's going to be 15.4 centimeter diameter, which will give me a probe distance from the back end of 8.74 as shown here, and then the length of the probe is embedded there somewhere. Is it 5 centimeters? So yeah, I'm going to use a Cantana, is it? And initially anyway, just see how we go. It's 15 centimeters. It's quite large, but being offset, I don't think it'll cast too much of a shadow onto the dish.
I will show at the end, briefly at least, some of the stuff I put together, because one of them includes a table I've tried to put together to show some of these dimensions for different diameters of cans. So you might find that helpful, because superficially the 8.74 looks a bit small, but I forget exactly what it is for 15.4 centimetres, but we'll check later on in the meeting.
Yeah. I did order a nano VNA, so I'm going to play with that once I've built it and just see exactly if it needs trimming or adjusting or whatever. Is that the way to proceed with that? I'm not quite sure, but I think it'll be the...
Yeah, but your issue is trying to get the distance right at the end, initially at least, because obviously it's not the free space wavelength that you're dealing with there, is it? So, but anyway, as I say, I've tried for my own benefit to put a table together, which might actually answer that question later on.
Yeah, okay, thank you, Andrew. So that's where we are at the moment. When the weather warms up a little bit, I can work in in my workshop without freezing. Then things the side may proceed a bit faster.
Paul, you're putting a bunch of effort into controlling the motor. Do you expect to use it daily instead of just a mechanical adjustment, or is it hard to get to?
No, it's quite easy to get to, and as the dish came with it was motorized when I had it removed from our motorhome. I thought I would use that just to and I quite like playing with electronics and feedback systems, and I wanted to explore the inclinometer and get that built and working properly almost as another project, really. I thought it would just be interesting. It's making it a little bit more complicated than is necessary, but I thought it'd be fun, basically.
I think we're talking about one motor, and that's going to be for elevation, angle above the horizon.
You're absolutely right. Yeah, that's what I'm working at. There is a second motor for rotation, which is for the azimuth, but I'm not going to implement that at this stage. I mean, if I get really clever and can work and have the time, I might. I have everything necessary to make it a track, but that's a bit further down the road and way beyond my pay grade at the moment.
Excellent. Well, good luck. Keep us informed.
I will do.
I have a question.
Yes.
From your block diagram, you were talking about using a Raspberry Pi 5 for driving things. It was about a million times more powerful than you needed. I was wondering what else you've got in mind to do with it.
Oh, right. Yeah, I know it's more than needed, but I've got a few lying. I've got a few here that I'm not using, so I tend to use a Raspberry Pi for dedicated projects, but I haven't got anything else at the moment that I'll use it for. But of course, if I get a second, if I can get a second dish built, which is the long-term project, then it'll be driving that as well.
Okay.
But it's still not working very hard. I agree.
Now, I have a quick question. Why did you decide to use the 12-volt lead-acid batteries to drive your system, and not just maybe just a power supply?
Yeah, I mean, again, I've got I have a lead-acid battery here. I'm going to run the power from my lab to the dish. And I thought that, well, as I've got the battery, it's going to be cleaner than having a switch mode driving it or something. So, I mean, that's the only reason. Again, it's just what I've got available.
So you'll be monitoring the battery voltage and just to make sure that you don't run it too low or.
Yeah. I've got a big car battery here that runs my UPS, and that has a display of voltage on it, so I will be monitoring that. Yeah.
I see.
Oh, well, thank you very much, Paul. Is there anybody else that would like to ask Paul or comment anything to Paul's discussion there? No, well, hi Heather, nice to see you. We were Paul was giving you credit for something that he's just been telling us about a bit earlier on, helping him to
Oh, that's
work out
scary.
the focal point of an offset dish.
Oh, yes, yes. That's quite a challenge. Yes.
Yeah, thank you very much, Heather. That was a wonderful link you gave me, and the tool it pointed to had all the information and answered all my questions, and I now know that the offset angle of my dish is 18.4 degrees.
Excellent. Okay.
Is it possible for you to share that link in the chat? That'd be an interesting reference link, if possible.
Okay, if Heather is able to put that in the chat, I'll pick it up and put it in the video a little bit later on.
Okay.
Okay.
That's fantastic.
Actually, Paul is probably better placed. I'm not sure I could dig that one up again.
Oh, Paul's just put it in, I think.
Yeah, excellent.
So let's just pull the chat up and we can have a look what it is there. So.
Oh, great. Thank you.
Yeah, so I've just pulled it up, so it's now in the video. It's www.sat.sig.net/pointing/finding-dish-offset-angle.hdm- and a whole pile of other stuff. But if you look at the video, it'll be there for you to see.
It gives a 404 error.
Ah.
Yeah.
Oh, okay. I'll tell you what, Paul. If you could send the tool to me, I will forward it out to all the members of the group. If you're able to, because it looks like it's an Excel spreadsheet or something. You're mute, by the way. Yeah. Okay. Right. So thank you very much, Paul. So I'd like to now move on to Andrew Sadowski, as opposed to Andrew Strong, because we have three of us. We seem to be growing Andrews in this meeting. So hi Andrew. Would you anything you'd like to talk about tonight?
Sure, I can give you a bit of an update on the.
Sorry, just to say, it looks like I think it's Ted might have found that particular link. So again, I've put that into it was in the chat, and it's now in the video as well. Okay.
So I can give you an update on the 3D printed waveguide feed horn. So for those of you who haven't seen it before, I'm starting with this design for the feed horn waveguide with the Kumar choke on it, and what I've been doing is looking at how to 3D print this and then seeing how they perform, which actually sort of leads on to what Andrew was talking about just prior. So this is the 3D printed horn. What I've actually made is I've made three versions of these with different diameters internal. So 148 millimeters, 158 millimeters, 168 millimeter, the internal. The external Kumar choke I've had to build in 4 parts and glue together, but the choke diameter has remained the same, so I've just changed the inner diameter of the choke for the different size horns in the middle. And then in order to make them reflective, what I did try was some copper impregnated PLA, and whilst that works as a reflector, what it doesn't allow you to do is get the ground voltage, because the copper impregnated is inside the plastic. So if you then try and put an amplifier on it, you lose all the amplification because you're not getting the ground voltage. So instead, I've been painting them with this.
We are still on slide 1. We see a picture with lots of little slides down the left-hand side. So we may be we may be sharing the wrong window.
Okay.
On this.
All right.
We want the big one.
Thanks, Ted. But I don't. Let me stop sharing. Let me stop sharing. Let me try again. Share. Let me go screen. I'll do it that way.
That's
Now
better.
we see the copper one. Good. And we see dots.
Right.
Good.
Okay, so that's the one you've been looking at all the time, yeah? So that's the 3D printed. Let me go back over this again. So I've printed 3 different diameters of the internal, 148 millimeters, 158, 168. The diameter of the outside cooling choke has remained the same. I've just altered the inner diameter of the choke to fit the different size feed horns, but I had to print this in 4 sections owing to my printer. And then in order to make it reflective, I've painted it with this MG Chemicals silver coated copper, which is highly efficient. I did try making one with aluminium foil stuck in there, and that does work. It's just much more difficult to get the aluminium in there and glued down, so it's just easier to use the paint. So I've just continued to use the paint. And so then what I've been doing is looking at, when you put the monopole in here, is, there's been lots of discussion over how high the monopole should be from the base, and there are various ways of calculating it, and then the different lengths of the monopole. So what I've done with these feed horns is I've drilled holes in them at 40, 50, 60, 70, 80, 90 and 100 millimeters from the base, and then I've put various probes in. And so this is then the results of looking at the 40 mil hole, the 50 mil hole, 60 mil hole, 70, etc., with the different length probes in them. So the one's nearest the axis is the position of the probe from the base, and these are the lower ones are the length of the probe. And then this is using the nano VNA, doing the VWSR. And if you're not aware of the VWSR, when you get closer to 1, it's better. As you move away from 1 and get higher numbers, it's worse. And so what you can see here is you can see for the 3 different probes, that's what the different colors represent, the changes that you get going from one level to the other. And basically, I was expecting much more change. I was expecting that at one point there would be a, ideal resonance and everything would be perfect. But as you can see, sort of when you get out to the edge, these 40 mil and 50 mil, there's a lot more variation. But you get in the middle here, 60, 70, 80, there's much less variation. You go up to 90 and 100 and you start getting broader variations again. And so, the question is, is there really an optimum point to put the probe and an optimum length of the probe? And so I've been fiddling around with this, and this is the same data but plotted in a hole position versus probe length. And you can see that there are some good positions here, and I'm waiting to prove that they are any better than any of the rest. But I'm wondering how much the return loss or the VWSR actually gives in terms of performance. So what I want to try and do is real world performance on these things. And surprise, surprise, when I was trying to work this out and I stuck a LED or LCD screen on a mini computer, I got this wonderful signal here at 1420. So this is noise from the LCD screen. And so what I've made the assumption is that this noise is constant. And so what I've done is put the various horns with the probes in various positions in front of it and measured the response from the actual horns. And so this is then the data, and it's a bit all over the place. You can see that there are some trends. Again, as you go into the early size, the performance gets worse coming this way. When you get in the middle, so the shorter probes are better. here the shorter probes are better. When you get into the 70 mil, it's the middle ones that are better, and when you get over this end, it's the larger probes that are better. And so, but you know, overall, there isn't a huge difference across the range. Maybe there is over here, but across the middle of this, the actual performance, you know, to me sort of doesn't vary greatly. But, you know, again, that's sort of against a noise rather than real signals. So what I'm doing at the moment is working through real signals. Again, I've plotted the same data on probe position versus probe length, and you can see that they're stacked all over the place. There's no real obvious trend in there. So if I then, this is all done inside a shed. It's not outside, it's inside a shed, so these signals are coming from the roof of the shed. I'm getting the signals from the Milky Way on just these feed horns and waveguides themselves, and plotting them out, and then looking at the maximum that signal you see across here, and then I'm plotting that against each position of the feed horn for each of the waveguide lengths, etc. So I'm slowly working through this real world data to see if there is a performance difference in them. And then on top of that, I've been playing around with software. I use the Despera software from the West Virginia University, and when I was using that, essentially the software, you have the input, it goes into a polyphase filter, then goes through the FFT, and then it goes into an integration, a moving average, and then it goes smoothing, display, and save. And with this, I'm using an AirSpy Mini, so I've got a 6 megabits per second sample rate, which gives you a 6 megahertz span, and the vector length, the number of points in that data set is 4096. And in the Despera software, you have the ability to change the integration time. And I thought that changing the integration time changed what happened here. But in reality, it doesn't. All it does is it comes over to here, and if you say you want to save every 10 seconds, it will count to when you've done 10 seconds
just checking you're okay, dear.
sample, and then it will save that sample at 10-second intervals. If you put 30 seconds, it will save them at 30-second intervals. So, not actually doing what I was hoping it was going to do.
Well, there's a hot water bottle waiting for you just inside the door.
Increasing
I'm in a meeting at the moment.
Integration that went into it to reduce some of the noise. So I've been playing with it a bit, and what I've done is taken the input. I've actually changed this now from here, but I'll go through it. Polyphase filter. You can then slice. Actually, this doesn't work. Sorry, I didn't update this design. You can't slice until after you've done the FFT. So you have to do the FFT, so polyphase filter, FFT, and then you can slice the output from the FFT. And so if you imagine this is the 4096 samples across your span, what I've done is I've set the frequency in the middle here such that 4020.4 megahertz is in the middle of this segment, the first 1024 data points over here. And so when you do that, you've got 1420.4 megahertz sitting here. You do the polyphase filter, you do the FFT, you can then slice it into 2 segments. So I take the 1024 points to the right of the center frequency and 1020.4 to the left of the center frequency, and then you can divide them, you can subtract them, whatever, and then process them all. In reality, what I've done is I've done all the integration and everything first, and then I slice over here and then save the different sections. But so in each spectrum, you can take the baseline and subtract it or divide it from the spectrum of interest. But with the data that I'm getting, with the signals being so low, I'm not actually seeing any benefit in doing so. But I'm still playing around with this and still trying to optimize it and work out the best way to do it. So that's what I wanted to share. It's a job still in progress.
Wow, that's incredible. I'm quite shocked by a bit of that data on the probe lengths and distances there. You read online it's supposed to be so important, and yet it doesn't seem to be. Did there seem to be some sort of periodic thing on it, or was that just completely false? It almost looked like it got worse every 10 millimeters, then got a bit better, then got worse, then got a bit better.
To sort of my interpretation, it shifts. So if you went down to 40 millimeters from the base, then the shorter probes were better. But if you went higher up to 100 millimeters, then the longer probes were better. I don't understand the relationship.
Did you show us your that initial slide, the one with the dimensions on it?
Yep. Come on. There. Okay, so that's from the literature, and so it's 154 millimeters diameter here. So mine are the same. It's 180, except instead of mine being 154, that's on the inside. So I've gone for the outside. So the outside is 148, 158, or 168.
Okay, interesting.
But as I say, the diameter of the Kumar choke has remained the same, 354 millimeters.
Right.
It's just I adjust the inner diameter here to fit the different feed horns.
Right. Okay. I was just interested comparing it to the 1296 things. It's interesting. I started modelling it last time, but didn't get very far. But I wanted to get the exact figures that you were using, so I'll keep running it through a model and see where we come up with.
Okay, thanks.
The work being done on this in the States at the moment.
Yeah, there's people here doing it.
On the
So sorry, who's that speaking?
Sorry, it's my husband who's leaning over my shoulder trying to tell me about stuff that's being done in the States, but we're all aware of what's...
With these solar cookers, some of the
Yeah, we're all aware of it, dear. You're
okay.
3 years behind us.
Yeah, okay.
It doesn't matter. It doesn't matter. You're very welcome. Do join us if you'd like to. You're very welcome to do so. Yeah. Okay, so well, thank you very much indeed. That was absolutely fantastic. Gosh, a bit mind blowing, really. So, who have I got next on my list here? I've got Ted. You're next. Would you like to talk about anything?
Me? Okay. Hi, everybody. From Loveland, Colorado. And I keep bubbling. It's cold weather, so I've been playing with software, doing stuff inside, and slowly making progress with GNU Radio. That's a whole another world to explore, and Andy even has another, I'll call it Zoom session, team session, to talk all about that world. And I've made progress with a collector. Andrew, I've just finally mailed you a copy of it as well. I'd be interested to see what you consider about that one. It even allows for taking reference samples, although it loses some efficiency that way. And then and of course storing it all in an Ezra.txt format, which is what I keep trying to support. So that's available, but only to those who come talk to me at this point, because I think there's some hand-holding in this new environment we need to talk about too. And it's so new, I'm not sure I believe it either. So we have to converse. I was studying how to highlight hydrogen. So let's say you have a drift scan of 24 hours going across the sky. That's great. What should you use for to improve the signal? You can study each sample by itself and compare the hydrogen frequencies against the non-hydrogen frequencies. In Ezra, I call that ANT-B. But there's another way where you could use some kind of reference, and either you could be recording references, or over the 24-hour period, if you think it's rather consistent measurements, go pick one and compare all those samples to the one that you chose. That's been in there for a long time by sample number. You can choose any one. And now I have a version of EasyCon, not yet quite posted, that takes some right ascension value, so some left-right position on the radio sky, and use that instead. So it's kind of different interface and perhaps more automatic. With a clean signal, it works really nicely and cleans up the hydrogen highlight very well. So that's the kind of stuff I'm playing with. If all this interests you, come find me. My webpage, I guess I'll post the Ezra stuff in the chat. And my email's at the bottom. Thanks.
Thanks, Ted. That's great. Is there anybody like to ask any questions to Ted or make any comments? You've left them dumbfounded there, Ted. Well, thank you very much indeed. The order I'm going through people here just happens to be whatever order I wrote you down as you were joining, or I happened to see on the screen, so it doesn't mean anything in particular. But next on my list is Adrian.
Let's see. Don't have a lot of stuff or anything prepared. I did have a couple of comments, and I think you kind of brought these up yesterday, Andrew, at the RTOP Sarah meeting, and that was this. I wouldn't call it discrepancy, but I'd call it sort of a change in the LNAs, the sawbirds. So here we have an older one, and one that I just got the other day. I guess it's from the newer batch.
Sorry, Aidan. So just point. I know most people on this group know what these are, but this is just for the sake of anybody that's watching the video online and perhaps hasn't seen these before. These are the New Alex Sawbird H1 low noise amplifiers and filters. Correct.
Yeah. So this is this is one of the older versions, and as you can see, the newer one has a significantly larger footprint, which is a little bit disconcerting, because you might want to actually, as Paul was doing, place these inside, since you want them close to your antenna. You might put them outside in some container, either for electrical protection, like the aluminum box that he's using, those bud boxes, or put them so that they're protected from the environment. So this larger one, the dimensions are a little bit larger, so you might have to, if you had like a previous installation with these guys, you might want to have to alter what you're going to use these for. And so I just thought I'd point that out again, because I think it's significant. They were all consistently, I've got about maybe 3 of these, and they're all identical in the dimensions. But now this is the latest one. That there was a sort of in a period there where there weren't available. You couldn't find these anywhere, and so now I guess Nulek, the company that manufactures this, got the new batch out, and they must have changed the aluminum enclosure, and so but they're very nice aluminum enclosures, and so it hasn't dropped in the quality of it. It's just, again, the dimensions, and that's something I noticed and didn't pay attention when I got the new one, but then after you pointed that out yesterday, Andrew, I went back and looked and said, yeah, wow, that's a significant change there. And so, and I know you mentioned earlier when you started the meet that, okay, I was trying to see what was it that Ted was saying there. When you started the meet, you said that you wanted to go outside and possibly change one of these LNAs to one of these reference LNAs that contain the 50 ohm onboard resistor that you can switch in and out. And so this is one of these. It's one of these what they call bare bones. And so it does have, I know it's hard to see in the picture, but right there's a little 4-pin connector, which is the one that actuates the internal switch to go between the antenna and then the internal 50 ohm resistor that you can use for, again, everyone hesitates to use the word calibration, but the reference signal that you might want to use to adjust for your system noise level. So I had this around, so I just thought I'd point out what they look like. And as you can see, this does the same function as the other ones. It's the low noise amplifier, and you would place it up next to your antenna.
Hey, Adrian,
Yeah.
Could you hold it in front of you? Your screen thingy, that's it. Your screen thingy is blanking it out.
Oh, okay. Is that better? I'm not sure if I get closer.
Yeah, that's working well.
If you can now see that, I know the automatic sort of background there kind of shuts it out.
Yeah.
Might be difficult. I've just written on there the frequency that it's for, because actually I have several of these guys that are somewhat similar. They're not the internal 50 ohm resistors, but they're for different frequencies. So Nulek has a whole series of these LNAs that you can purchase for some of the satellites, whether you want to receive the weather satellite pictures and so forth. And so I just wanted to, that's why I've written on the 1420, so I can identify it whenever I want to pick it out from my box of LNAs. So I just thought I'd point that out, some of these units that are available, and get that difference. So I had something else that I was looking at. I'm not sure if I'll be able to present it. I can give it a shot. And basically, I'm somewhat concerned. This is data that I've gathered over several years from the 20-meter green bank radio telescope that SARA members have access to. I actually had access to it prior to even joining SARA from a class that I took from the green bank telescope. So let me see if I can actually get this to work. And let's see. It might not. Again, I'm not familiar with the usage of the share button here, but let's see. I can try that. I don't know if it's doing anything. Okay. I'm not sure. Is that coming through at all on the share?
At the moment, there's no share coming through, Adrian.
Okay. Well, gosh.
Are you pressing the share button?
Yeah, I'm hitting it, but it doesn't seem to be doing much of anything. Let's see. Window.
Ah, it's working now.
Oh, okay. Let's see. I'm not sure if I'll be able to get this done. So this is okay. What this is, it's a raster scan. You can see over on the left there the pattern where sort of raster goes through the area designated. And what you're looking at there is the Orion gas nebula at the hydroxyl maser emission lines. And so that's basically at the top there at one frequency, which is more like around 1665, 1667. And then there's a second emission line at 1612, and that's these bottom frames that you see there. And as you can see, they're somewhat in the same, because the position doesn't change, so you can see the relative location of where the 1665 and 1667 hydroxyl maser emission lines are designate the nebula. And there's sort of outlined there a much weaker signal at these bottom ones. But what you see there are these incredibly sort of horizontal lines of essentially radio frequency interference. And the best deduction is these are satellites that are operating in that closer to that 1612 megahertz emission line. And so again, this was taken back in 1921, and so there was already a significant amount of the interference there at the 1612 emission lines. And so again, what I wanted to point out, and let me see if this will work, was the next series of what I of the same, exactly the same object, the Orion Gas Nebula. And this is one that was taken a little bit earlier this year, like around January or February, I think. And again, you see the top 16, 65, 67 emission. And what you're seeing there in these two panels are basically the Greenbank radio telescope has a simultaneous detection of two polarization axes. So it has an X and a Y, and so they give you the output from each one of those on each one of those two patterns depicted on the top pictures there. And then on the bottom slide, again, you see kind of that 1612 frequency where you get a lot of the satellite interference. And you can see, well, in one horizontal line, because this also depends. These are, especially if they're like Starlinks, they're low altitude orbit satellites, so they're moving past the antenna. The antenna is sitting there looking at the fixed, relatively fixed astronomical object, the gas nebula, but the satellites are going by in the low Earth orbit, so you can see those streaks essentially as they go across the screen. So there might have been a few less in the and they're fairly polarized signals that these satellites put out. They're not exactly linear, horizontal and vertical. I think they're more circularly polarized, but there's still some discrimination between the two X and Y axes that the Greenbank telescope can detect them. But as you can see, there's still a significant amount of these satellites coming by and the interference. In this case, the 1612 signal might have been a little bit stronger on one polarization, and that's one of the things about these maser emissions, that they're somewhat variable with their polarization and intensity at some of these frequencies. And so you can see that bottom right one at the Y polarization, the Orion Nebula was a little bit brighter. But again, the main thing I want to point out here is just these satellites and the interference pattern that they're causing. And this is the most recent one then, series of scans that I took of the Orion Nebula. And so on the 1612, there might have been a few less satellites, but now what you can see here is that before, on the other two scans, the other two periods, where the 1667-65 signal was pretty clean. There wasn't anything really interfering. Oops. Well, okay. I accidentally hit... I think I might have deleted that last slide, and so I don't know if I can actually bring that back, but I hope you got a glimpse of it. You can, if you saw that there was just one of these satellites coming by and interfering, even at the other frequency of 1667 for the Orion Nebula. So I guess my point is that as these satellite constellations keep increasing, in terms of the density of these satellites that are causing the interference for radio astronomy. Some of these observations might get much more difficult to be able to obtain. So that was kind of basically my point that I just wanted to show there. Besides the actual scans, and so that's pretty much what I had to say. And so I'm again also having the problem with unsharing. Let's see. Okay. I think I stopped sharing there. I hope I did. So if that was it, then
Yeah, you have, Adrian. Very well, thank you.
Okay, great. Thanks. I hope everybody's having a good New Year. We had some really horrible weather here in Southern California. Oh, I'm in San Diego, California, and we just had horrible storms coming through this last week. Wind gusts probably up to 50 miles an hour, and actually had damage done to an antenna, not for radio astronomy. It's a disco antenna that I use for just regular scanning. It had it on a tripod and had it toppled over by the winds and snapped off quite a few of the elements on the antenna. So I'm kind of bummed out over that. Hard to replace. But anyway, I understand the weather you're having there in England. At least it's kind of snow. I hope it's just cold and not too windy.
Oh, our idea of snow here is nothing compared with what you guys tend to get in the US. It's a light speckling relatively here. Yeah. Okay, moving on to the next person. So, Ian, as you've joined us this evening, is there anything that you would like to talk about? Oh, you are muted.
There we go. Sorry about that.
No, that's fine.
Yeah, all I can say is wow. The conversations I've listened to this evening are all expiring. This is all pretty new to me, the hydrogen line. Traditionally, I started, as you probably know, Andrew, some many years ago now, with just monitoring SIDS and monitoring radio signals from Jupiter, all manner of things. Just recently, I've been part of the Global Meteor Network, doing video meteorography with live views of meteors. Some clever people out there doing spectroscopy with those. But since I've been ill, I've sort of pretty much drew a line under everything, tore everything down, and I'm going to start again. So this seems a good point to sort of listen to you guys and see what you're doing. As I say, I think I mentioned earlier, Andrew, I picked up finally the Sawbird. I think, was it Adrian said there was a switch? Was that the bare bones unit? Because I've got a unit here, which is the actual assembled version. There's no switches on this at all.
No, there's not. No, it's only on that other unit that had the just the bare back. And there's one of those. I'm sure he can show his unit that he can display that. But those units are just straight through antenna input and then output, and so there's no ability to switch with that any other function.
So, are there any hardware? Because it says on here it's a V4 version 4, and I just wondered if there was any data sheets indicating that there'd been some hardware modifications, anything like that. But on the NULEC site, it's very sparse.
Yeah, that's unfortunately the problem. NULEC doesn't give you very much information. They don't give you any circuit details. You don't know what the active devices are. You'd have to strip it down and look. So you just gotta have to plug it in and use it and take their word for it.
But the problem is first you have to get it. What Andrew held up, I can't find on their website anymore. Andy, can you buy a bare bones with a resistor in it anymore?
Well, I think I've just managed to get hold of one.
I've got one.
By personal request, I think.
Yeah, when did you buy that, Andrew?
Just over Christmas.
And where did you buy that from?
Amazon?
Yes, I also bought mine from Amazon, but as Ted,
Oh, good. Okay.
yeah, well, but as you say, Ted, there aren't any on the New Elect website. And for Ian's, because he's just joined us and won't be aware of this. So the version 4, let's take the version. So version 1 is the one that Adrian showed up before, the smaller version. Version 4 is the new one with an aluminium enclosure that's in the bigger box. That's version 4. Version 2 and 3 are meant to be, supposedly, according to Noelec, 2 different versions of the bare bones. Bare bones being one without an enclosure on it. So they sell all their, or they used to sell all their LNAs with and without an enclosure. And supposedly, I say this, supposedly there are 2 versions of the bare bones doing the rounds. One that has the internal resistor and one that doesn't have the internal resistor. Because there was some concern about an increase in noise levels if you used the internal resistor, or if the internal resistor was in the circuit. However, it's interesting that Newelec no longer have it on their website at all, and various people who've come onto the SARA forum have felt that there has been a resistor in whichever one they've got, and the one that I seem to have bought now, and I'm assuming the one that Andrew's bought as well, looks as though it's got a resistor in it. Would you agree with that, Andrew? Oh, you.
That's what the information says.
Yeah.
Yeah.
So I'm going to go out on a limb and suggest that there is no such thing as the version without a resistor in general circulation, and that what's happened is that if you buy them, they generally have got a resistor in them, but actually they're no longer being produced. But it's just a way of doing a reference sample. There are many ways of doing a reference sample, of which by far the easiest is Ted's very simple processing built into Ezra, where it just uses an offset frequency. Default is 1423 megahertz, but you can change it to whatever frequency you want.
And if I might add, you can, even if you are not able to accomplish purchasing one of these bare bones with the 50 ohm reference built in, there are external boards that you can get from Amazon, even sells them, or even eBay, that accomplish pretty much the same thing. They're switched somewhat differently, but I don't know if Andrew's pointing one of those out. So you can purchase these boards that will do the same thing externally. Now, whether they have somewhat higher reduction in your input signal, it's hard to say. If you look at the specification sheets for several of these, they vary in terms of their input signal loss, and so you have to kind of look at that and determine whether the
It's after your and my discussion recently, Adrian.
Right. Yeah. So we have to you have to determine whether that's something that you can use or not. Now that's not the switch that you actually had, right? That gave you the large noise drop, Andrew. Is that the?
No. This you remember you and I were discussing when we met
the
up.
Boards on.
And there were boards on
okay.
Amazon, and that's one of them that's come through, like a $5 each or something. I forget what chip's in this, well, what's in yours there, Andrew?
HMC 544.
Ah, well, something like that. So there are various chips that will allow you to, as Adrian's saying, to switch in and out the an external resistor. I mean, maybe Andrew, when Ian's finished, perhaps you could show us that board in a second. Is there anything else you'd like to talk about, Ian?
No, I'm listening carefully and intently, but I'm slowly collecting this stuff. I think it was the meeting in Oxford where the guy from Japan did the demonstration of his hydrogen line receiver with the floppy cone. That I started to build that. Started using various filters and LNAs, and I think I got it to sort of the software to kick in once, but since then I decided to take the plunge and order one of these Sawbirds. But Yeah, no, I'm feeling a lot better. I think I'm going to start assembling these things and see what results I'm going to start to get. But yeah, if there's any wikis or anything or plans to do so, that would be really, really useful for newbies like myself. But yeah, that's pretty much all I've got to say. And thank you, guys. I'll hand you over back to you, Andrew.
Yeah, before Andrew takes over there, I'd just like to give everyone a warning. Yesterday we had a long chat on the SARA RTOP meeting, and then an after meeting on the role of AI. So here's my warning. If you type in hydrogen line telescopes or Cantenna at the moment and ask it for the references that it uses, it comes up with a particular website at the end, which it seems to give a lot of credit to, and this website is astronomy.me.uk. Now, I know this website very well because it's my website, and it worries me that that's what multiple AIs are using as their source of expertise, because I know what I put on it. So given that that is the case, can I point out that if any of you go on my website and find an error, or at least multiple errors, then please point them out to me and we'll at least put a correction on there if nothing else.
You sit at the radio astronomy throne, Andrew.
The worst thing is it doesn't even say it's just a blog. It presents it as being some sense of some source of expertise, and I'm quite worried that Astropelia, for example, doesn't come up at all. And Wolfgang's mob are true expertise, but there we are. That's the way these things work. Yeah. So passing over to yourself, Andrew. I'm interested to see this little board that you've got here and what you've been doing with it.
Okay. So what I'm looking at is I'm looking to put in hot and cold calibration into the data stream, and so what I've got is the Sawbird, which has got the internal switch in it. And then I've got this second board, the HMC544, which is an RF switch, basically. And so I can have the cold junction on here, and I'm assuming this is going to be the hot one because it will have the electronics power from the circuit board. So this is going to be the hot one. And then the output to the SPI device, or the receiver, comes down there, and then obviously the antenna comes off here. And so what I'm doing is I'm building this within GNU Radio, talking to an Arduino to do the switching. And so with the Arduino, I've got a 4 relay board, and when you go on the website, there's a website blog that shows you how to drive this. And surprisingly, they have 5-volt input to this, but when you look at the relay boards, they're 12-volt relays. So 5-volt doesn't do anything. So what I've had to do is get a buck converter to take 12-volt into here to power this board, but then take 5-volt out of the buck converter to go to the switching. And so I'm in the process of building that and printing off the 3D boxes to put everything in. So that's what I'm working on. I've got software that seems to work, but it needs to be proven. And I need to work out, one of Ted's problems was when you switch, how long do you have to wait for the signal to decay so you get the reference that you're looking at or the signal from the antenna. So I'll be playing with that over the next few weeks.
Yeah, just to say, I bought a couple of those relay boards there. If you look on Amazon, they are available as 5-volt versions, literally, that will run the relays at 5 volts. There are 12-volt versions, and there are also 24-volt versions. So you're quite timely for you to point out those differences so that people make sure they buy the right ones that they want. I think all of them will take up to 240 volts in what will actually go through the relay itself.
Yeah.
To be switched, but you'd have to double check what's written on the relays. Yeah. But thank you very much for that. That's really quite interesting. So with hot and cold calibration being added in by using one of the bare bones. So if anybody does want to pick up one of the bare bone boards, bear in mind they're no longer being produced by New Elect, so it's more a question that if you can find one somewhere, I ordered a second one yesterday myself off Amazon, and it said it was the last one that it had. I don't know whether they'll have any more or not. Depends whether some resellers got any. Okay. Right, now we unpin you. Okay, thank you very much there, Andrew, and thanks very much, Ian there. Thank you very much indeed. So now I've got Richard here. Is Richard still around? Yeah, Richard, would you like to talk about anything? Oh, perhaps Richard's not able to speak to us. Okay, so I'll move on to Chris.
Good evening. I just presume I'm the only Chris on.
Yeah, sorry, Chris. Yeah,
Good evening.
I'm trying to point out where there's multiple people, but you're as well to ask the question.
Been interested in hydrogen line for, I suppose, about 15 years, but never managed to progress very far with it. I've tried various antennas. A lot of it was at one point, I think, work overtook me, and then since retirement I got into other things, and I now find really I'm trying to do so many things that I suppose it's the thing about when you retire, you think you've got hours and hours to put things right and do things. I have failed on that. Health has been giving me problems as well. So consequently, I've got start of the system. I did try doing it with a Yagi, and built myself a couple of Yagis with printed plastic T-pieces, like the Tonner aerial arrays. Was as nearest I got to it working, but that was actually unsuccessful, I'm afraid. And also I couldn't follow that any further because I'd also made the mistake of using a plastic that wasn't capable of standing outside in the UV, so I had problems with that as well. And I just simply not got round to it. And then I received this email from you the other day saying that this was on tonight, and I thought, yes, perhaps it's about time now that I got on with it and had another go at it, because at the moment all I can claim is unsuccessful, but still very interested. So thank you very much for inviting me on. I just realised I also cut my camera off at that point, but I'm sure quite a few of you, and I've met several of you before on the other sites. So. But yes, thanks for letting me know it was on, and I shall try and stay if you can. Let me know when your further meeting's on. I'll try and join you. I don't think I'm going to be at the moment very active, but I'm interested. Let's put it like that.
Yeah, well, there's a number of people here, Chris, that don't currently have a project, and maybe will never have a project, but are expressing interest, and you're extremely welcome to take part. The more the merrier, really. As you probably noticed, there are some people who know a lot, but there are some of us who, if we appear to know anything, are just pretending, and some of us who definitely don't know anything very much at all, of which I put myself in that category. I'm just very good at making myself look like I know things, that's all. So it is great having you here, and thank you very much indeed for coming and joining us. Okay, so next person, Andrew Strong. Would you like to take the floor about anything?
Yeah, so I'm here in Munich. It's about a year since I discovered that this group existed. I just was curious whether people did that, and discovered that they did, and I ordered, let's see, where is it? It is. I ordered that about a year ago, and it turned up by delivered at my door, and I was a bit surprised, and so I unpacked it and stuck it on a broomstick, and basically about as far as I've got. But
is that the Discovery dish?
It's a Discovery dish, yeah.
Yeah.
So I got it there on the thing. I mean, apart from that, I do this sort of astronomy. I do optical a lot. But some bit from a background of radio as well. Anyway, so I got it, and it's there, and I haven't got. And then I discovered I needed to buy all these things from Noelec, and I have bought them all, and they're sitting here in a box, and I have to work out how to cobble them all together, basically. And I bought myself a laptop specially just for that. And yes, I'm just going to keep on. And it seems to me there's quite a learning curve here, and I'm definitely on the beginning of this learning curve. So I want to just start to. I thought the best thing was simply to buy all those bits and then actually have them in my hand, and then start to see how I can connect them together.
Well, if you would like the two of us to meet up and talk through that next process, if that would be of help to you, then
absolutely,
then just drop me an email and we'll set a meeting date. And very, very happy to do that.
Like you.
Oops, you've gone. You've gone muted again. Well, I'll leave. I'll be back.
Yeah, if we could have another between the two of us, a session where you helped me about 6 months ago, I think, whatever it was.
Yeah,
to come a bit further.
That would be very,
very
helpful.
If I could suggest, you're already in Germany. I mean, I'm sure that if you took a field trip out to the Stockard Observatory, that would be a
great, because I have, and there are radio astronomers. There are amateurs here in Germany too.
Yeah, so if you did that, I'm sure there'd be numerous numbers of individuals out there that are much more experts than any of us here, and wonderful equipment. Yeah.
Yeah. So there's also the German Astronomical Society, and I've only just joined it, and they have a radio astronomy group. So the people at Stockholm, so they're Effelsberg and so
exactly right. Yeah.
Just in my far background, when I was in Durham doing my PhD on cosmic rays, I went to twice to Parkes to make an H1 survey of the galactic plane, and and we published it and wrote it up. But I cannot get my hands anymore on the public or anything, which annoys me a bit. But anyway, so working on it.
It's worth saying. Adrian's mentioned I think it was Adrian before mentioned the 20 meter. Was it yourself that mentioned the 20 meter scope earlier on, Adrian?
Yeah, all the stuff that I presented was
that's right.
The Greenbank 20 meter accessible radio telescope in Greenbank, North Carolina. Yeah.
Yeah. So
anyone can use that, can they, online or something?
Well, if you're a member of the SARA, it's a U.S. group, but I mean it's global. So anybody from around the world, we have people from Switzerland and Russia and members from all over the world, Australia, and very inexpensive. I think it's like a $20 annual membership or something, and you can actually get the log on password and so forth for the Greenbank radio telescope, and it's accessible. You can just go there and apply whatever object that you might be interested in observing that's within the capabilities of it. People do pulsars, and as I showed, I had these objects that are called masers, and masers are kind of the equivalent of lasers, but in microwave, and these molecules in these molecular clouds can emit these signals, and so you can do all these different observations, and hydrogen line, and so that's accessible to SARA members. So you don't even have to have any equipment if you so desire, and then just join SARA and log on and use the telescope.
I did actually join SARA but I haven't gone any further with it. But I'll try doing that.
Brilliant. Thank you very much indeed for that. That's highly recommended for anybody that hasn't done it. Okay. So, Dave, would you like to talk on anything?
Hi, Andy. Yeah, sure, okay. Yes, couple of bits, couple of things I've been up to. Yeah, okay, let me do the old thing, you share the screen bit. I'll show you what I'm up to. I've got multiple screens here, so hopefully I'll get the right one. Let's try sharing screen 2. So, are you now seeing a multi-image view? Probably not.
No, yes we are. Yes we are.
You are? Brilliant. Okay, right, okay. So, yeah, this is what I've been up to. Last time I talked about, I've got a 1.5 metre dish, which has been working reasonably well up to now. I got into a bit of a high observing hiatus for various reasons. I couldn't do any observing, but I was able to work in the workshop. And I've had this sort of idea for a while to enlarge it to from 1.5 to 1.9. And I know, Andy, I spoke to you some time ago about this, and you advised me not to bother. Said it'd be more trouble than it's worth. But in sort of true tradition, I thought I'll ignore all that and I'll just do it anyway. And so this is as far as I've got.
So just to say, that was probably a good move on your behalf. Generally ignoring anything I suggest is a generally good move. So good on you.
The social. I know you said you did that. I know you said that you ignored people's advice in the early days, so I thought I'd copy you. Anyway, yeah. So the idea here is, because I know that I can manage with this 1.5. I can, because I have to be portable with my setup. I can't leave it out permanently for various reasons. And 1.5, yeah, I can carry it around and it's practical. And I thought I'd go bigger than that. It's not going to be practical. But I thought, if I make some bolt-on extensions, like you see over here, and I bolt them on in 4 pieces, then I can just sort of set it up a bit like the way Eduard does. Then I might just give it a go and see what happens. So far I've fully built two of these outer segments. The last 2 are sort of partially built at the moment. I'm hoping to finish them off in the next few days and attach them on, and then fire it up and see what difference it makes, if any. And if it makes no difference, or it's just too unwieldy and impractical, well, it doesn't matter. I can just chuck those segments back, into the corner of the shed and forget about it. But if it does work, then it might be an interesting thing to try. So I think what this is going to do is going to drop my FD down to 0.37 to 0.3, and that maybe reduce spillover. I know that Alex Peckett's always on about that, isn't he? Cranking your edges up a bit. So I thought I'd try that, just to see what it makes. Maybe it'll improve my SNR. Maybe it'll drop my beam width a bit. Don't know. Thought I'd build it up and give it a try. And then I'm also, meanwhile, this is a mock-up I sort of mocked it up yesterday. But meanwhile, I'm actually doing some observing at the moment, and I'm looking at trying to do some comparisons of result quality for various setups. So, Andy, inspired by your work, I'm trying to do a comparison of 1-day and 7-day drift scan data collections, and look to see what the quality differences that I can see. I know you've got some amazing results, but I wanted to sort of just try that for myself. And I also plan to try 8 and 10 bit data. See if that makes a difference. And then once I've got, because I should then have these outer 2 segments fired up, then do a comparison of 1.5 and 1.9 metre dishes. And just, again, all I'm going to do is all up standardised on one declination, so I can do like for like, apples for apples comparisons, and see what what differences, if any, I can see, and that might then suggest my direction of study for the next maybe for the rest of the year. So that's where I've been up to.
Oh, thank you very much. That's excellent. Just to say, I can't remember what I said to you before, but it's just worth saying that recently I've had some conversations with Alex Pettit, and he tells me that in his view that extending the edge of the dish is one of the best changes that you can make to improve performance of these dishes. Essentially, its main benefit is to reduce ground reflections or reflections from elsewhere. And most of us are in small gardens, and our dishes are quite close to the ground, so we've got a certain amount of RFI wandering around. So I think you may well see a significant improvement.
Yeah. So I read those posts too, Andrew. And yeah, I think that was one of the things that inspired me just to say, "Oh, the hell with it! I'll just go and do it and see what happens." So yeah. Anyway, maybe next meeting I can report back and tell you what I found.
Yeah, brilliant, absolutely fantastic. Thank you very much indeed. I look forward to seeing that. I'm sure the rest of us will too. So marvelous. Okay. So who have I got next? Heather, would you like to talk about anything?
I'm going to be the weak link in this because I haven't done anything over Christmas, so nothing new to report, I'm afraid. I like many people here, have got my bag of bits and a dish, and still haven't put the two together. But making progress, but not enough to talk about.
Oh, that's fine. It's just great having you here. That's marvelous.
Heather, can I ask you a question? Weren't you working on a receiver for the 22 gigahertz frequency range? How's that coming along? I'm really interested in that band. It's just hard to get equipment for that frequency, except for some satellite type receivers.
I'm trying to find it. It's somewhere behind me. I don't know. It's vanished. Yeah, we found a source of. I think it was a radio point-to-point link, which we've managed to get some of the bits for anyway. It's got a mixer and a filter and an amplifier and some other bits. So Brian Coleman, he talked to us. Was it last month? I think. He's gone away and doing some work on that. Oh yeah, okay. There it is. That's the original unit. And yeah, that's what's that? Oh, okay, that's an amplifier out of it. But yeah, that's kind of as far as we got with that. As to yeah, I mean, everything becomes plumbing in this world. As you will have gathered, you've got a filter here and an amplifier here and an oscillator here. So yeah, there's very little electronics and an awful lot more plumbing.
Is the oscillator GPS stabilized or just a?
It isn't,
Okay.
but it feeds into a mixer multiplier, which means that we could replace the oscillator with something that is locked, and yeah, hopefully go from there. But it's kind of a bit early days yet. What Brian's first approach was going to be was to try and measure the system noise, the noise temperature, and see whether we were in the right ballpark or not. Because yeah, I mean the people who've been doing this are doing it with big dishes, very big dishes, and we've only got 3 or 4 meter dishes here, so it may be that we won't get much out of it at all. But we're optimistic. But yeah, if I make any progress with that, I'll let you know.
Oh yeah, it would be very interesting because I know yesterday in the SARA meeting there was a presentation. There's this one member in Switzerland that does a lot of the water macers at 22 gigahertz, and he only has like a very small, like a 1 meter dish, and he's using one of these television satellite LNBs for 22 gigahertz, and he's getting some very interesting results. Even such a small dish. It's steerable, so he can integrate for a while. But anyway, yeah, that's fantastic. I'm really interested in that band. So Good luck on your progress. I'd love to hear what you do with it.
Paul's just there's a feed.
Yes, tiny.
So,
oh my
yeah.
gosh, yeah.
Is that a homemade feed or one that you bought online?
No, that's a commercial one, some variety.
Yeah, it's hard to make that yourself. Very hard.
Well, yeah, I don't know if you know, in the UK anyway, there's Neil Smith, G4DBN. He's making a lot of really good stuff on his CNC machines. So if we get close enough, we can probably persuade him to design us up a feed horn and make it. But we'll see. Yep, that's kind of where we are.
Fantastic. Good luck.
Thank you.
Yeah. Okay. Brilliant. So I think it's just myself that's left. Is there anybody here that I've missed out? No.
Say, Andrew, I wanted to I don't know if I could show something very quickly.
Go for it.
You were talking about modifications on dishes, perhaps maybe to lower the kind of the side lobes and maybe get some of the radio frequency interference type or ground noise to be reduced. And there's this there's a new radio telescope array system that's being built here in I believe it's Utah, and it's called the New Synoptic Array. I'm not sure, or the Deep Synoptic Array, I think is the name of it. So I'm not sure if anybody's heard of it, but I've got a sort of the image from the website. But I'd just like to see if you guys can take a look at these dishes and see what you think about it. So let me see if I can get this on.
Wow.
Is that coming through now?
Yes, it has indeed.
Okay, so you can see the what they're doing there at the edge of these dishes. They don't really explain why. As I said, they're just building this system now. But I can only imagine that it serves a very similar purpose for what you were just describing in terms of maybe reducing ground noise, and that might be something that we might think about if somebody wants to go off and modify a dish and do something like that. Anyway, I just thought I'd show that. It seems interesting when I saw it the other day. If that's of interest to people.
I believe it's a technique for reducing the lower side lobes of the mirror.
Right, and does the ground noise and everything else. Yeah, right.
Yeah.
Okay, well.
Yeah.
I just thought I'd present that and see what everyone thought about it. Okay, now let me see if I can unshare here. Boy, it is hard to find this stuff. Okay, and okay, I think I went off.
Brilliant.
All right.
Right. Okay, so I wanted to. How are you all doing for time? Anyone able to hang around for another? I'll tell you what, before I present anything, let's just set a date for the next meeting in case anyone needs to shoot off. So normally we have these on the first Monday of each month. So that would be the 2nd of February. Would that date be okay for everyone? Okay, the second.
Good for me.
As there's no objections, that's the.
Good for me, Andrew.
In that case, that's the date it is.
Good for me.
Yeah.
I'm sorry, could you repeat the date, Andrew?
So that would be the 2nd of February.
Okay.
Yep. All the best, Paul. Look forward to seeing you next time. Okay, right. So he's not going to miss out too much, but just a couple of things I wanted to show. Firstly, little toy that arrived through the post. I thought I'd have a go at making a horn. Okay, I've got dishes. I don't really need one, but found this one on eBay, so you can find something cheap. I can't say no. So this is a WR 650 waveguide, not to be mixed up with. There seems to be two different wavelengths that get mixed up with that same sort of designation. One with a much smaller device with a much higher frequency, and then this one, which is the right size for hydrogen line. So if you ever do decide to buy something like that online, be careful what you're actually buying. So now the next bit is, how do I make the horn section to go on the front of it? And so I got a horn calculator, and I worked out how big it was, and was a bit shocked at just how big the pieces needed to be for an ideal flaring. But that's the next task. The second thing I wanted to mention was, as we were talking about before, with these little boards, which I mentioned with Adrian earlier on, and also Andrew was showing on his board. So there's a number of these little switching boards. I think they came up after the last meeting, and some of the stuff that we're having on the SARA mailing list. A couple of different chips that you can get. Some of them are a bit. There's an 849 chip if you want to go for the cheapest one, but you're talking about £5 to £10. And probably the most important lesson, which is what poor Adrian here has learnt, is you can order the chip itself for about that sort of price, or maybe even a bit cheaper. Then it turns up and you find you've got this tiny little chip, and you've got to try and solder it onto something. Well, that's the problem you found, wasn't it? And you're an expert at soldering.
Yeah.
Or you could pay £5 extra, go on to eBay or Amazon and get it ready, soldered onto a little board for you, complete with SMA connectors on the end of it. So just worth bearing that in mind. So that would allow you as an alternative for if you haven't got a bare bones, or you want to try and do a switching technique without using the bare bones. But as a caveat, I would just say it was worth saying that the general conclusion on the SARA mailing list, like lots of these different bits and pieces, is you can do a reasonable job without needing all these extra bits. So you can do frequency switching to get a good reference signal, or Alex Pettit's current preference is to try and take another bit of signal away from the hydrogen line out of the same plot. And I know that Ted and I have been trying to do that quite a bit, but there is an issue there with how flat the baseline is, and there's also an issue with RFI, which we're still trying to sort out. And if we get that all resolved for you, we will let you know how you can do that particular one, which would effectively double the number of samples that you're taking, or that you're taking in a given time, or double the amount of time that you've got to integrate, because you wouldn't be having to switch in and out some sort of reference device at the same time. But we'll come back to you on that one. But for anybody who's just starting, I would just go for the frequency switching technique, because it works really well and it's really easy and you don't need any extra bits of kit. So the other thing I wanted to show is I tried to do some calculations, as I mentioned earlier on, which may or may not be correct and may or may not be any use, but I'm going to show them to you anyway. So this is a picture which has come out of the Astropelia documentation, showing their cantenna, or their stovepipe cantenna that they made, and gives a basic idea of Astropelia's suggested dimensions. That they were using one that was 150 millimeters across at the top, or 6 inches for you guys over the other side of the pond, and 9.3 centimeters or 93 millimeters from the base. So these are the two. So that the two critical dimensions, or at least when you read online about these things, supposedly the two critical dimensions are the distance from the monopole probe there, or at least through the chassis connector that we've got there, through to the base, and also the length of the monopole probe on the inside. Andrew Sitaski tonight has already sort of gone a long way to debunk the idea that critical dimension to the bottom is real, but nevertheless that's what the stuff still says. It certainly is dependent, at least in terms of the calculators, on that diameter. So that does change a few of the things inside the can, which is really what I wanted to show you today. You can make these cans for a variety of devices. The ones I'm currently using are using a coffee can of an appropriate size. The stovepipes are very common as well, or you can make one just using some sheet aluminium and bending it around a former. Bear in mind that it's going to be outside, so you have to be aware of what you can do to stop it from rusting. In my case, because I'm using a coffee can which is made of light steel, it does mean it needs to be covered with a load of plastic. So Barry, I can't pronounce his name, Malovanquick here, is the guy that produced the design specifications that are on the my mind's suddenly gone blank, the SETI League website. Just suddenly, forgive me, my brain's going bonkers. The SETI League website. So I just done a bit of a paste here of some of his dimensions. So this is what he came up with. He was using a slightly bigger can in terms of 156 millimeters at the end, and that left him with the total length of the can is 278 millimeters. The choke ring, as you can see, is 360, which is almost exactly the same as the 354, which Andrew was quoting a bit earlier on. And the depth of the choke ring of 106 millimeters, which is again virtually the same as Andrew's earlier on. The coaxial probe at 4.6, which is interesting because that seems quite small, and his placement of his coaxial probe at 88 millimeters from the back. So I got another calculator, and just to show the length of the monopole probe there, it's 4.6 centimeters. So I perhaps this diagram just gives an idea of the basic principle of a can. We've had these before earlier in the meeting tonight, but just to remind you. So the basic principle, we've got 3/4 of a wavelength of the length of the can. In this particular case, it's a flange rather than an obvious choke. In this case, a flange is just trying to collect a bit more data. But there are issues about how big a flange you can have and its dimensions. So they have to be careful. You can't just shove any old thing on it. And as you can see, normally they say it's the wavelength inside the can, or a quarter of it from the base up to the probe is what's normally quoted, with the sort of free wavelength divided by 4 being the actual length of the monopole itself. At least that's what's quoted until Andrew came along tonight and came up with his figures. So I did some calculations. It's according to the calculator which I used, you start to run into problems below 125 millimeters, and you run into problems above 161 millimeters. That's the diameter of your can. So it's worth saying that you can calculate things anywhere between those particular values, with 150 millimeter being the oft quoted amateur size or thereabouts. And the thing that stands out from these calculations to me is that the ideal can length dramatically increases the shorter the diameter. However, this is probably the least important measurement. The probe length stays about the same, and which is why I'm interested in the SETI League statement that the probe length than he came up with, which interests me. And you can see then that the distance from the probe to the bottom of the can decreases as the diameter goes up. And again, that can be quite significant, over a couple of centimeters increase in diameter. So it's worth bearing those things in mind. These two radiuses here, radius 1 is the same radius as the one on the left-hand side. That's just the radius of the can, and radius 2 is the supposedly ideal radius of the choke, supposedly. So I was interested as well that Andrew had kept his choke at the same size regardless. I don't know how important that is. The choke ultimately is there to again try and prevent spillover more than anything else. And I think that's it that I wanted to say. So just hand back to any other comments that anybody would like to make on that.
Yeah, I'd like to make a comment regarding Andrew's experiments with the probe placement. And I'm just kind of throwing this out there. I'm not even sure if this has anything to do with it. But I'm sure you're familiar with Q factor, Andrew, correct?
Yeah.
So I'm just curious if, you have a fairly sort of low sort of density metallic content for the printed feed that you're generating, and I know that, for example, on a tuned circuit, one of the ways that you can make it be more broad frequency responsive rather than have a very sharp tune is to lower the Q factor on it. And so I'm just curious if perhaps just the fact that the walls and so forth of the printed material have significantly lower Q. I mean, if you read anything about waveguides and cavity tunes and so forth, people go to extremes. I mean, they do silver plating on it in order to make that the most conductive and highest Q possible. And so I'm just curious if perhaps that might not have an influence on the placement of the probe by not having a very sharp sort of frequency response, and then having a much more broader response, and not having then the sensitivity towards the reflections of the incoming electromagnetic waves that should theoretically coincide with the quarter wavelength where the probe should sit. So anyway, I'm just sort of theorizing, and I'm just curious if perhaps that might have something to do with it, and just something to think about.
Yeah, it's possible.
I've got to say, after Andrew's figures earlier on, I'm beginning to wonder how many of these deeply held beliefs are in fact based in fact, or whether they're based in just being standard practice. But it's going to be interesting to see how often have people really, especially in something like hydrogen line, how often have people actually tested these things in the real world? So it's certainly an issue that, as you all know, I recently retired as a GP, but it's something which in medicine over the last 30 or 40 years has come to the fore, the idea that there was a lot of things that were being done to patients just because that was the way they were always being done, rather than because there was any research to back it up, and probably still is now, in all honesty. Anyway, what do you guys think of my my waveguide? I don't know why there's a big, thick, bumpy bit on the end of the probe. Can anybody get any idea why that would be there?
Yeah, usually that broadens the frequency response. The thicker the probe, the wider the response for the probes.
Oh, right, okay.
So the thinner, the more resonant it is at one particular frequency. Again, sort of what we were describing now in terms of broadness of the responsive circuits and whatnot. Mm-hmm. So with probes, that's kind of the standard sort of description, is that the thicker it is, the broader the response and the frequency. It's not as sharp as when you have a smaller diameter for the wavelength that it's supposedly tuned for.
The other thing that interests me is Shake's surprising answer when he was asked, did his 120 centimetre dish perform better or worse than his 70 or 80 centimetre horn, and he felt the horn performed better. I just wondered, I mean, given there's quite a lot of room on a dish for when you think of the RMS on there at 21 centimetres compared to, say, visual RMS room when you're doing astrophotography or visual astronomy. I just wonder why he would see the horn perform better than his dish. Unless that's...
Well, is it really a perfect parabola? Maybe he is. By the time he layered the paper and layered the aluminum foil and layered all the various sort of reflective surfaces, it might not necessarily be a a very accurate parabola. It might have started out in the forms, but in the end, maybe the reflection doesn't really have a very good focal point.
Well,
By the way.
maybe, but the reason I was asking that, Sheikh, was because if I'm doing astrophotography and I get a mirror that's got a 10th wave RMS accuracy on its surface, then I think I'm doing really well. I probably spent a fortune on that mirror. I certainly don't expect 20th wave, and yet 20th wave at 2.21 centimetres is a whole centimetre. You could have very crinkly silver foil and still be within a centimetre.
Is there an efficiency factor difference between horns and parabolas? I'm only thinking about this in very crude terms, but a parabola has to turn the signal through 180 degrees, reflect it through, well, not 180, but through, some angle, 90 up to almost 180, whereas a horn's directing the signal in the almost the same direction without having to try and turn it round. So, is there an efficiency factor involved in that's in working in the horn's favour through that method? Because I built a horn and I found my horn was great, it was really good.
I don't know it's an efficiency factor, but in terms of a dish, you're reflecting the signal into something else. So you've got to have that mechanical alignment perfect to get optimum signal, where with a horn, it just comes straight down.
So you can't go wrong almost, can you? Well, harder anyway.
Is everyone here familiar with the Hubble story?
Yeah.
I mean, when they first put it up in orbit, it had a perfectly ground mirror. I mean, the surface accuracy on that thing was like unbelievable. One of the best ground mirrors ever made in that size. And yet, when they first did the first observation, it was a blurry mess because it had more of a spherical shape than a parabolic shape. They ground a perfectly surface mirror to the wrong shape, and the focus was horrible. They actually had to send up the repair mission to put a Morris contacts on it to correct for the spherical aberration on it. So I mean, you have the same thing in a parabola. If it's not a perfect parabola, you don't have a good fine focus. It's going to be spread out, and it's not going to be. It's not. You're going to lose a lot of the signal. As Andrew said, a funnel, a horn, just funnels the signal in for whatever diameter it is. I'm sure you have some losses. You have internal reflections of the signal and so forth, but you don't have to focus it to a fine point. It just gets funneled. So I can see how for a given degree of inaccuracies that the funnel would be superior than a poorly made dish, and you still get reflections from the dish, but if you don't have a good focus, you're going to lose a lot of that signal in spherical aberration or just spillover or whatever outside of your feed. So I can easily see how a parabolic dish could go a lot wrong, much more, than a horn.
So
but,
if
anyway,
that's the
that's my
case,
opinion.
how much do the dimensions of the horn section of the horn matter? I mean, so I've got my, it's described as as a sort of waveguide to coaxial adapter, is what they're described as. But basically, it's a square section at the bottom with the coax on it, and this has got the right dimensions. It's got the right diameter and the right height and all that sort of rubbish that for hydrogen line. But the flared section at the end, the horn section, my reading online suggested it was important, but is it really important? And does the angle really matter, or can you just stick any old pieces of aluminium or whatever on the end of it that you have hanging around to make some sort of flared section?
Well, the basic concept, Andrew, is that collecting area is collecting area.
Yeah, but
So
angle is
Well, yeah,
important, because if your
Sure.
angle's too steep, you're not actually going to funnel it in. So
True. As I said earlier, you might have internal reflections that bounce your signal back out even. But basically, if you just look at signal, you have X amount of signal that's being projected into a particular area. The more area you have, the more signal you can collect. I mean, that's why people make bigger dishes. But obviously, the quality of the dish and the quality of the horn matter. But the main thing, of course, is just the collecting area.
That
And then, of course,
horn is an impedance matching thing. You see it also on loudspeakers when you're trying to address a whole field of people, where it's nice and curved, coming from a small little thing into a great big horn shape. That curve is actually a impedance conversion, transfer.
Yeah, matching.
And so there's a whole bunch of math behind it. And a cone is the first approximation. Big is good. Sure, why not go for it? But, of course, maybe you want to see just a small part of the sky, too. So, but I think you need that impedance transformation. What is it? What's the right word?
Matching. Impedance
matching, I guess. That's what we're looking at.
You're absolutely correct, yeah. You know, bad big is not good.
So that's the real math behind it. And we cheat like crazy.
Yeah.
Yeah, I think it's important to understand that it doesn't work the same way as water does. If you pour water into a cone, the water all gets focused down into the bottom and drops out the bottom. But that's not what's happening here. It's taking basically a parallel wavefront and converting it into another parallel wavefront that'll go into a waveguide, which is what you have at the bottom. So it's trying to do the same thing as a dish, but without using reflections on a planar reflection. It's using wavefront reflections to basically get the whole thing to focus in. So it's a little bit more complicated than maybe it seems at first. But it's one of those things. Maybe we should have a bit of a talk about how to simulate these things and what's going on inside these things. Because whilst I see your figures, Andrew Thornett, where you've said basically you just scale everything, but in reality that doesn't work very well, because there's an awful lot of impedance changes which cause it to be non-linear, which is why if you look at optimized designs for amateur radio bands, they don't all come out nice and neatly at 1/4 and half wavelengths. There's all sorts of little odds and ends going on in there. Anyway, yeah, there we go.
Thank you. That's. I can't say that I know the answer, but I've now realised that I know there's a few more questions I should be asking or finding out the answers to. So, have you given us a topic for another meeting? And any volunteers, contact me if you can give us a talk on those things, on how to simulate antennae and horns and things. Okay.
I might be able to. I've done some horn simulations. Yeah. Okay. I'll see if I can get something together for next month.
Oh, marvellous. Thank you very much, Heather. That'd be fantastic. Yeah, I think actually that'll be really interesting. A talk on horn design for next month would be fantastic.
That's the horn that I built. I built several of them. It's just galvanised steel sprayed with galvanised paint. But it's just a cone feeding down to the waveguide where the monopole is. And the plastic box on the bottom is where the electronics go, the amplifiers, etc.
So do you, rather silly question, but do do you drill a hole in the bottom of it so any water drops out?
Yeah, there's a tiny hole in the bottom, and I use outdoor table cover to go over the top to keep atmosphere out.
All right, and you can leave that on all the time, can you?
Yeah.
All right, okay. Oh, very good. And how big a horn have you built?
So that's 750 millimeters across.
All right, okay. Oh, very interesting. Yeah, I'd like to have a go at making one and see what I can come up with.
Yeah, horns have a very long, important history in terms of radio and microwaves. It was a very large type of horn that discovered the cosmic microwave background that resulted in a couple of Nobel Prizes out of that. But it wasn't a dish.
But of course, that one bent around through 90 degrees at the end, didn't it?
Well, it has a back end that's not a pure funnel. It's actually a sort of a parabolic surface.
Mm.
So it's not just a plain flat 90-degree turn. It actually has almost like a sort of a reflecting surface in the back. So you're kind of cheating a little bit, but it's not a true parabola. But it's kind of a lensing back surface. It has to be engineered to. Again, as Heather was saying, to funnel those parallel waves back into the feed horn.
I mean, looking at horn calculations that I can find online, not that I understand them, but looking at them, they seem to be, because of the slant required, they seem to be very long. So if you went silly and said, I want something that's 3 meters diameter at the end, you end up with something that's like, I don't know, sort of 8 meters long or something silly. And I just wondered, conceptually, not that I want to do it, but could you then take part of the horn and turn it into a spiral so that it actually shrinks it down? I'm just wondering anyway. There we are. But maybe getting a bit silly now at this time of night. Okay, is there anything else that anyone would like to talk about before we finish? Well, in that case, I would like to say thank you all very much indeed for joining me tonight in this meeting and for everything that we've discussed, which has been very exciting, and I'm very much looking forward to the next meeting and learning more. So I hope that you have a great week, and if you're in the UK, that the snow's not too bad, and if you're in America, that those storms are abating a bit for you. Okay, all the best to you. Bye-bye now, guys.